Ladies and gentlemen, batteries in our lifts used to have a very long lifetime. Because of the continuous charging systems, batteries lasted sometimes 15 years or longer, but rarely less than 10 years. And suddenly we see batteries go bad after 1 to 2 years, even less sometimes. We've tried to find the reason for this, and now we think we know what it is. To properly explain that, we need to give you some basic information. First, we have installed a lift in a freestander to test the system as a whole under maximum load for 3-4 months. The procedure was lifting up to the highest possible point with maximum weight. Wait a minute, lower all the way down, wait 4 minutes, lift up again, etc. And these 5 minutes pause was just enough to charge up the batteries with the amount of energy that was taken out of it during the lifting and lowering process. The system did never show any low battery status. Unexpected, we left the lift sitting for a week, not using a lift, and the charger was connected, and then we find out that the battery were low, meaning discharge. And we were puzzled. Why would that be? When we pushed the button to activate the lift again, the charger came on, the charging indicator light went from green to orange. It was charging the batteries were charged up, the lift would work again with no problem. How can that be that we have lifts that are heavily used and the batteries are depleted and charged up, depleted and charged up again, and no problem with the batteries were seen? And then we leave a lift sitting there without any work, without any function, without any use, and the batteries are depleted and are in a bad condition. Information on those batteries. You can measure the voltage of a battery. You can measure the amperage when you have a load attached. That means you can measure the discharge of the battery. But you cannot measure the electric capacity of a battery that easy. You have to empty the battery totally and count the performance, count what you have taken out of the battery. For example, a fully charged battery, let's say a 12-volt battery, lead acid, is powering a motor. The amperage of the motor is 2 amperes. The voltage is in the beginning, let's say 13 volts. Stop the discharging process and wait a little time, and the voltage will be back at 13 volts. So the voltage stays for a long time steady. So the discharge curve of the battery will be, if you have a load on it, let's say here you have the voltage and here you have the amperage, it will stay for a long time in that curve and then go down. Meaning here you have, let's say, the 13 volts and here is the amperage drawn. And when you have a load attached to the motor and run the battery and undischarge the battery by running the motor, then the 13 volts will stay a time, and then it will shortly drop. Leave it sitting there, leave the battery sitting there with no use, no draw of energy, and the voltage will climb up again to 13 volts. You can measure 13 volts also in an almost empty battery. That means that a half full, half empty battery shows the same voltage as a fully charged one. Explaining this would take us a little bit too far into battery chemistry, but I'm sure everybody knows what I mean. Now to chargers. A battery charger is a device that stores energy in a battery by running an electric current through it. The charging protocol depends on the size and type of the battery being charged. The charger may have temperature or voltage sensing circuits and a microprocessor controlling to safely adjust the charging current and the voltage. A so-called trickle charger provides a relatively small amount of current, only enough to counteract the self-discharge of the battery. Remember, a battery discharges itself only by sitting there, usually 1%. That's what the discharge rate is of a lead-acid battery. That is what we are using. A trickle charger only charges up what we have taken out for the lifting process before. The chargers we use transform 115 volts AC to 24 or in some cases 36 volts DC by first flipping the sinus curve voltage AC to the same level, then the tops of the curves are flattened. If we see the AC starting like this, that is the sinus curve that we have for AC. And what we do in a transformer is, number one, we take that away and flip it upwards. So this is taken away, and then in the second step we flatten these curves and make this to a flat, straight DC current. Now comes the easy part. The charger compares the 24 volts or 36 volts respectively. Let's say 24 volts direct current. It compares the 24 volts from the batteries with the 24 volts of the charger coming from the charger, and are both equal values. The battery is full and the charger can reduce the flow of energy. So far so good, but we don't have a charger. A charger that we had was a transformer, this part of it, and then a few electronic components to do what we've said here. What we have, or what everybody has, there's not really a charger on the market anymore. Everybody has switched mode power supplies. What is a switched mode power supply? A switched mode power supply is an electronic power supply that incorporates a switching regulator to convert electrical power efficiently. Like other power supplies, it transfers power from a DC or AC source to DC loads while converting voltage and current characteristics. Unlike a linear power supply that we have here in our chargers, the pass transistor of a switching mode supply continually switches between low dissipation, full on and full off states, and spends very little time in the high dissipation transitions, which minimizes wasted energy. Hypothetically, ideal switched mode power supply dissipates no power. Voltage regulation is achieved by varying the ratio of on to off time, meaning if I have a 120 volts AC source and have a 24 volts DC load, the transistor switches on and off so often that altogether, counting altogether the on times, is the same as if I had, like with a direct charger, I had the 24 volts 1 amp, for example. Switched mode power supplies can also be substantially smaller and lighter than a linear supply, like a charger, because the transformer can be much smaller. Everybody has that, you know it. We had, and this is the large one for an iPhone, there were much smaller ones, and they have also 1 amp output, and this one is much heavier, a charger, direct supply of power, and this one is a switch mode power supply, much smaller, and this one has the same output like this one. Much heavier, more cost, nobody's using it anymore. Everybody's going to switch mode power supplies. Well, switching regulators are used as replacements for linear regulators when smaller size or lighter weight is required. They are less expensive, but however more complicated. Switching currents can cause electrical noise problems if not carefully suppressed. Simple designs may have a poor power factor, and if I have here on the output side a 120 volts output which is switched on and switched off in a time, let's say 100 hertz, so 100 times per second on and off, or 200 times per second on and off. It's all depending on what I want to achieve on the output side. That means, how will this one know that the battery is full? It cannot determine if the battery is full. Also, it has to read the voltage of the battery to find out whether the battery is full or not. Now, we have learned before that the battery is a minute after the use showing again in that fact that we had, that example that we had, 13 volts. So this power supply cannot determine that the battery is in a lower stage. This one fills it up so that the electricity level is the same, on the same level. This one doesn't know that. It is, once it is charging, it is charging for a while, determined by the program on this equipment. That means with these chargers not used and the voltage stays the same, the battery is over time depleted. If you push a button and run the motor, and the motor decreases the voltage or the amperage, takes out amps from the charger, and the voltage is going down a bit, these chargers are filling up the batteries fully. No problem, never had a problem with it. These ones don't do it. And nobody has regular chargers. We had to go back, redesign chargers to be able to have a maintenance-free system. So we're going back to the old chargers. Doesn't mean that these are bad. It's just that they give the battery the chance to deplete completely. I hope this makes sense. If there are, and I'm sure there are, questions about that, we cannot, or I can receive emails from va.gov, but I cannot send emails to va.gov. I'm sending them out and I'm reading they're gone, but they are not received. unless they come from inbound in the US address or